Okay, this is going to be part 3 of the video series on trigonometric integrals involving sine and cosine. Now, if you haven't done it yet, I would definitely watch the first 2 videos because they will explain this series of steps and how to use them, and we're just going to do a different problem this time. Now, in the last video, we did one where the power of the sine was odd. In this video, we'll do one where the power of the cosine is odd, so we'll wind up using the second guideline right here. Now, before we get around to the problem, just like in the previous videos, you will need just a quick reminder of some trig identities and derivatives. So let's take a quick look at those. And just a reminder from your trig days, the sine squared is equal to 1 minus the cosine squared, and the cosine squared is equal to 1 minus the sine squared. So you'll need those identities. And also a couple of derivatives on these problems. Just a reminder, the derivative of the sine of x is equal to the cosine of x, and the derivative of the cosine of x is equal to the negative of the sine of x. So with that in mind, let's go ahead and take a look at a problem. We'll just do one problem in this video, and again, it will look like this. So what we've got here is this. We've got a problem, the integral of the cosine to the fifth times the sine squared dx. Now in this case, the cosine is to an odd power, so we've got the cosine to the fifth power. So looking back at the guidelines for solving these, the recommendation is this. If the power of the cosine is odd, then take one of the cosines, move it off to the side and save it, and then convert the remaining factors to sine. So what does this mean? Well, let's run through it. So what we'll do is this. We've got 5 cosines here. We're going to take one of these cosines and move it over to right here. And that will allow us to complete U-Substitution. So let's see what that's going to look like. So this would be the integral now. Now remember, you had 5 cosines. If you move one of them out of the way, now you've got 4 cosines left over. So 3x, and it looks like that. Then here's the sine squared of 3x. And now you took one cosine. When you move it over here, you've got a single cosine, 3x, sitting right here. And from the previous videos, if you watched those, and hopefully you have, just a reminder, is this last cosine, the whole purpose of moving this last cosine off to the side is so that you can use it to complete the U-substitution later on, because the derivative of the sine will get you to the cosine, and you'll be able to get rid of this part right here. So, next step. Now you want to take all the part that's left over, this part over here, and change it all into sine. So how do you do that? Well, it's going to take some identities. So first of all, we'll write it like this. Now here is a cosine to the fourth, but you don't have an identity for the cosine to the fourth, but you do have one for cosine squared. So the next little trick on these problems is take this cosine to the fourth and change it into cosine squared. So I'll make it be the cosine squared of 3x. Now that's going to be squared. So squared, squared, multiply them, and you get cosine of the fourth. So you've still got 4 cosines there, but you just rewrote it so that you can use the trig identity, the cosine squared is equal to 1 minus the sine squared. Now after that, you've still got this sine squared right here. So you've got a sine squared of 3x. And you've still got this cosine of 3x dx out here. Okay, now the next thing. You want to change this part, try to get it entirely into sines, and what you're going to do is looking inside the parentheses here, 1 minus the cosine, or pardon me, the cosine squared will change into 1 minus the sine squared of 3x. And then put parentheses around it, and you still got this squared sitting out here. Then you still got the sine squared, and you've still got the extra cosine out here. So that gets you to that. Okay, now looking at this term right here, what this is, it's if you square it, it's like having 1 minus sine squared times 1 minus the sine squared. So on this step, you'll actually have to FOIL this little thing right here. So you're going to use the first, outer, inner, last, and actually FOIL that step out. So when you do that, it will turn into the integral of, now again, the first ones would be 1 times 1 would be 1. Then you've got minus the sine, which would be minus 2 times the sine squared of 3x. And then finally the last one, sine squared times sine squared would turn into sine to the fourth, and it will be plus the sine to the fourth of 3x. We'll put parentheses around that. So what that is, this is what it looks like. If you take this and FOIL it, it'll turn into this. Now you've still got this sine squared right here. And you've still got this cosine squared out here. So these things get a little long. dx. So it looks like that. Okay, the next step, and we'll scoot things down here just a little bit. The next step now is to do this. Take this sine squared right here and distribute it all the way through this. So this thing times this, and times this. So you've got to distribute that. So this will be the integral of, now 1 times the sine squared would give you the sine squared of 3x. Then you've got 9 minus 2. Then sine squared times sine squared would give you sine to the 4th of 3x. And then finally, sine to the 4th times sine squared would give you sine to the 6th of 3x. So the sine to the 6th power of 3x. And put parentheses around that, and then you've still got this cosine of 3x sitting out here. Okay, now we're going to put one more step in just to show you how the U-substitution goes into this, just to rewrite it where it looks a little different. Rather than leaving it as sine squared, I'm going to take each one of these powers and kind of move them out to the outside. So this first one would be the sine of 3x squared minus 2 times the sine of 3x to the 4th power plus the sine of 3x, the whole thing to the 6th power. Then again, here's the cosine of 3x out here. Now you don't have to do this step, but I think it helps when you do the U-substitution. Again, in U-substitution, we're going to try to eliminate this right here. And what happens, look inside each one of these parentheses. This makes it clear that here's a sine x, or sine 3x, here's a sine 3x, here's a sine 3x. So we're going to let that be our choice of u. Because the derivative of the sine of 3x will get rid of the cosine. So let's go ahead now and just do the U-substitution. So at this point, you're going to let u be equal to the sine of 3x. Now find the derivative of that. So the derivative of u with respect to x would be equal to, now the derivative of the sine is the cosine, 3x. But remember, this is a composite function, so it's times the derivative of what's on the inside, which would be a 3. So that gets you to du would be equal to, I'll take this 3 and move it out in front. So 3 times the cosine of 3x, and then this will be dx. Now again, I need to get rid of a cosine of 3x dx. I don't need a 3 on this side, so I'll move it to this other side. So this will become 1/3 du would be equal to the cosine of 3x dx. Now this matches up with this, so there's my U-substitution right there. I'm going to substitute 1/3 du. So let's go ahead and change it now from a problem in terms of x into a problem in terms of u. So what this is going to give you is the integral of, now this first thing will turn into u squared. So you've got u squared minus 2u to the 4th plus u to the 6th. So those all turn into u's. And then in place of the cosine of 3x dx, put what it's equal to, which is 1/3 du. So there's the U-substitution. And again, we'll move things down just a bit. Next thing to do is go ahead and take this 1/3. So take the 1/3 and move it out in front. So this will become 1/3 of the integral of u squared minus 2u to the 4th plus u to the 6th du. Okay, we'll go ahead and find the antiderivatives of each of those. So this would be 1/3 of, and I'll put them in brackets here, this is going to become u cubed divided by 3 minus 2 times u to the 5th divided by 5, and then finally plus u to the 7th divided by 7, and then you're going to attach a plus c on the end of all this. And you're almost finished now. It's just a matter of changing each one of those u's back into what they're equal to. Now remember, every u is equal to, I think we'll put it up here, u is equal to the sine of 3x, so change each one of your u's back into the sine of 3x. So we'll move this down a bit. And we'll also go ahead and distribute this 3 as we go through this. So this would turn into 1, the first term would be 1/9, so this will be 1/9 of u cubed, but u is the sine of 3x cubed. Then you've got minus, now it'd be 2 over 15, so you'll have 2 over 15 when you distribute the 1/3 times. Again, this will be u to the 5th, but that would be the sine of 3x to the 5th. And then finally plus, and again distribute the 1/3, this would be 1 over 21. And again, replace the u with the sine of 3x. Now to the 7th power and tack on a plus c, and you've got it. So that's going to be the entire solution right there. Now again, kind of going back up to the beginning, let's take a quick look at the whole thing again. The idea, since you've got it to an odd power, move one of the cosines over here by itself. Then take what's left over, change it from the cosine to the 4th into the cosine squared squared, because that will allow you to use your trig identity. So you want to change all this part into sines. Now remember, when you've got this, you've got to FOIL this thing. So FOIL this, then take the sine squared and distribute the sine squared, which gets you down to this step. Then it's just a matter of doing U-Substitution. So you'll do the U-Substitution from there, replace each one of these with u's, find the derivative, and then at the very end of the problem, change all the u's back into sines again. And really that's it. So there's an example of a cosine to an odd power.